Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about Algebra 2, Chapter 1, Day 4. This is aligned with Big Ideas. We are going to solve multivariable systems. So the multivariable systems, normally in Algebra 1, we cover regular systems of equations with two variables, an x and a y. But as you go further in math, you're going to have 3, 4, 5, maybe 10 variables. And this is kind of like a stepping stone to something called matrices. And matrices show up in pre-calculus, sometimes in later algebra 2. But this is kind of like your stepping stone. This is kind of like you're getting your feet wet. And so what's happening with these multivariable systems is our goal is to combine a couple of equations so that we eliminate one of the variables, and then we go in and we combine those two equations, and then we solve for one variable, solve for the next, solve for the next. That's kind of like your three-step process, I think it was. So the first thing I like to do is I like to label them. Especially for beginning students who are learning this in the beginning, when you label them, you kind of know what you've already done without having to like think and rethink about it. So for example, I can tell that my z right here is a negative z, and I have over here a positive z. So if I can combine these two equations here, this equation number 2 and equation number 3, I would essentially eliminate my z's, and that would be super simple because one is positive, one is negative. They'll create that zero pair, and I'll be done with the z's, right? And then I can go in and have just the x and y available. So I'm going to go over here and I'm going to just write that I'm going to combine the 2 and 3 equations here. Now, I can also combine the first and third equation because z is negative, and here I have z is positive, right? So if I combine the first and third, I am going to have to do some math in order to adjust this third equation so that I can get this to be a negative 2z instead of a regular negative z. But it's not super hard. It's not anything ridiculous. We can definitely do that. It just needs to be like planned out, okay? So step one is going to be to kind of combine these two equations and eliminate one of the variables. And it'll have to be eliminating the same exact variable. Here's why. So let's take a look. I'm going to go in and I'm going to combine these two. And the way that I combine is I just add them. Let's make sure I have everything. Okay, so 2x plus 3x is 5x. Then I have negative 3 plus 4 is y. And then the z's will cancel, and then that's going to give me 2. So now I have an equation that has an x and a y, which is something that I'm used to from Algebra 1. So let's take a look at this first and third. I have x minus 6y plus 2z equals 5. And then I have this third equation here. And the reason why I can't just combine these two as is because my x's won't cancel. So I'm actually going to take this second equation and I'm going to multiply it by 2. The whole entire equation, I'm just going to double everything. And so I'm going to end up with 6x plus 8y minus 2z equals negative 4. And then I'm going to bring this guy down here just to make my life easier so that I can see them one on top of the other. You don't have to, you can just combine this and this row. I like it for ease of visualization, I guess. It makes my life easier to explain things. Okay. So then I'm going to combine these guys, these two equations, and then I have 6x plus 1x is 7x, 8y minus 6y is 2y. And now the z's cancel because I have one negative 2, one positive 2, and that equals 1. So my second step, so first step is making sure that those equations are just eliminating the same variable. And sometimes you can eliminate the x, the y, the z. Just take a look and see which one feels more natural, which one feels a little bit easier to eliminate. So the second step is now I have these two equations. that only have two variables, which is what I've known from Algebra 1 with regard to solving a system of equations, what I've known from previous courses. It totally makes sense, okay? So I have two options here. Because the y is on its own, I can go in and subtract 5x from both sides and manipulate this equation to get y on its own, so that I can take this and substitute it for y in this equation. So I'll be left with just an x variable in my equation. I kind of like the substitution piece in this case, because if not, then I'd have to go in and multiply this whole equation by -2. And that's more math. And the more math you have to do, the more chances of error you have. And that's not really the best way to do math. We want to be as efficient as humanly possible, right? So I would recommend doing this step. Now, if you're like, wait, but I tried this and it totally got me the right answer, that's not wrong. It's just not as efficient, or it's not as comfortable as it is for me as it is for you, okay? It's not wrong. It's just a different method. Okay. So now I'm going to have this 7x plus 2, and I'm going to insert this -5x plus 2 in place of the y that's here, equals 1. Now that I have one variable, I can solve for x. So I'm going to go ahead and I'm going to distribute this 2. I'm going to end up with 7x minus 10x plus 4 equals 1. And then 7 minus 10 is -3x plus 4 equals 1. I'm going to subtract 4 from both sides. I'm going to also bring this up here. It's going to be -3x equals -3. If I divide both sides by -3, I'm going to end up with x is 1. So I've just now solved for my very first variable. Great, I know that x is 1. So now I can actually plug it into this equation here so that I can see, hey, I need to solve for y. So I'm going to go in and I'm going to say y equals -5 times 1 plus 2. So y equals -5 plus 2. So y equals -3. So now I have the x solved for and the y solved for. I can go in and solve for my final z. So a couple of ways that I can do this. I can choose any of these equations, not a problem. My favorite equation for right now is probably going to be this one, because my z is positive. So I'm going to replace the x with 1, because I know that that's 1 down here. My y with -3, because that's what I got for here, plus z equals 4. I'm going to combine like terms, do this math. So 2 plus 9 plus z equals 4. 2 plus 9 is 11, plus z is 4. Subtract 11 from both sides, z is -7. Now, some teachers are totally fine with you having your answers just x, y, z randomly on your paper. Some teachers want a specific method. So some teachers might say, no, you must absolutely give me a set of coordinate points. So you're going to go in this x, y, z fashion, where you're going to have 1, -3, -7, and then that's going to be your final answer. So it just depends on what your teacher prefers. I frankly don't care. I know that some teachers, as specifically as you go further on in math, when solving these multivariable systems, the pink highlighted answer is the more algebraic. But I think if you're doing this as your first exposure to multivariable systems, it's kind of like where you can be. I'm okay with that. Okay. So let's try this second one again, right? So the first thing that I'm going to do is I'm going to label these 1, 2, 3 again, because I'm new to these systems, right? You don't have to do that all the time. The second thing that I'm going to think about is, okay, what variable do I want to eliminate? Now I can very easily eliminate all three of these variables because I have a negative z and a positive z. I can then go in and multiply this top equation by 2 so I can eliminate the z's. I can eliminate these two y's and very easily multiply this equation by 2 to get a negative 2y so that I can eliminate the y's. And then I can do the same thing with the x's and then multiply this third equation by 2 to get the negative 2x's. So it doesn't quite matter which one I choose, so long as I choose one and stick with it in both methods, right? In both cases of which ones I'm going to work with. So let's say I'm going to choose x. So I'm going to choose the first and the third equation to eliminate my x first. And then I'm going to choose the second and third equation to eliminate my x again. Okay, so let's rewrite my first and third. That's the weird looking 2 minus x plus 2y plus 2z equals 10. And then I'm just going to combine all of the things that are the same. The x's will cancel. I'm going to be left with 3y plus z equals 8. And then if I take this second equation, oh my gosh, I'm like, my eyeballs keep moving back and forth to make sure that I have the right numbers. Okay. So I can't just combine all of these because then nothing will really cancel. I'll still be left with 3 variables, and that's not what I'm looking for. So I'm going to multiply this by 2 to make sure that I have a negative 2x. And I'm going to multiply the whole equation, so every single term, including the last term on the other side of the equal sign. So I'm going to have negative 2x, then I'll have plus 4y plus 4z equals 20. And then just like last time, so that I have them one on top of the other, I'm going to bring this guy down here. Okay. These guys will cancel because they're exactly the same, and I'm just going to combine all of them. So I'm going to end up with 3y plus 5z equals 28. Okay, so in this case, I have, again, 2 options. Option 1 is to move this 3y over to the other side and replace this z with whatever is going to be on this side of the equal sign. That's option 1. Option 2, like I said before, is we can actually stack these guys one on top of the other. So I want to show you this method as well, because sometimes this method also makes sense. And it might even make more sense now. If you notice, I have 3y in both cases. What I can do is I can actually, instead of add the 2 equations, I can subtract the 2 equations. So I'll go 3y minus 3y, and that'll cancel. And then I'll have 5 minus a negative z. So options are I can leave it like this, or I can even go in and distribute this negative. So I'll be left with the first equation will stay as is, but the second equation, we're going to have our negative distributed. And it'll be a little bit easier to see what I need to do. So I'll be left with 6z equals 20. That's kind of gross. So z equals 10 over 3, which is meh, not my favorite thing. Okay, so once I have z, I can then replace the z with 10 over 3 and solve for y. So I'm going to choose this one so that I don't have to multiply z by anything. So 3y plus 10 over 3 equals 8. I can subtract 10 over 3. Whoops, subtract 10 over 3. And this is, I don't know what's happening with my pen. I'm going to actually turn the 8 into 8 over 1 and make it into something over 3. So 24 over 3 minus this 10 over 3. So 3y, that will cancel. And then this is kind of like no more because we've changed it into different fractions. So this will be 14 over 3. And then in order to eliminate this 3, I can multiply both sides by 1/3. And I get y is 14 over 9. Another gross number, but definitely doable. And so now because I have the y and the z, I can actually replace it. And I would prefer to do this because this is the only place where my x is positive. So I'm going to replace the y with 14 over 9. And the z, I'm actually going to change this 10 over 3 into something over 9. And so I know I have to multiply the bottom by 3. So I'll do the same with the top, so that I already have these common denominators in order for me to be able to combine like terms. So 14 minus 30 is negative 16 over 9, or I guess, actually, let's not do that. Let's do x minus 16 over 9 equals negative 2 over 1. Let's change that to something over 9. So negative 18 over 9. So I'm going to rewrite this like that. And then I can add this 16 over 9 to both sides. So x is negative 2/9. And again, you can leave it like this. I wouldn't be offended by any stretch of the imagination, but some teachers do have preference. So just make sure that you're paying attention to what your teacher prefers. So do they prefer kind of, each individually, or do they want one big coordinate point? So again, sometimes it does make sense to go in and solve for y and get y on its own, or whatever variable on its own. Sometimes it doesn't. Sometimes it makes sense to just combine another set of equations. Okay, let's take a look at this one. So again, I'm gonna label them because this is likely one of your first interactions with these, and I want to make sure that I'm labeling things correctly. So option for this one, I would recommend not eliminating the z's because they all have a coefficient, and I know I'm going to have to multiply them, and they're all negative coefficients. So I would prefer not to deal with that. I can eliminate the x's and just multiply the first equation by a negative 3 to eliminate the x's in the second equation. And then by negative 2 to eliminate the x's for the third equation. So I'm going to go ahead and eliminate, sorry for that doorbell. I think my UPS delivery has arrived. Okay. So, okay. So I have x plus 4y minus 3z is 1, 3x plus 12y minus, actually, before we do all that jazz, so that I don't have to rewrite it again, let's multiply this guy by negative 3. And then I'm going to do the same thing here so that I remember that that's what I wanted to do. I'm going to multiply this whole business by negative 2. So I'm going to end up with negative 3x minus 12y plus 9z equals negative 3. And then I'm going to bring the second equation in here. And holy smokes, I want you to take a look at what's happening. This will cancel, this will cancel, this will cancel. So I'm going to end up with 0 equals 5. And that, my dearies, is a false statement. And because it is a false statement, there is no solution here. There is not one single point where all 3 equations meet. Anytime there is a false statement, there is no solution. Okay, let's go in with our final equation. And I'm looking at this and I'm kind of getting nervous that this one might also be no solution. So let's take a look. I can absolutely go in and eliminate the y's because I have 2 positives and 1 negative. So I can work with equation 1 and 2 to eliminate the y's, and equation 2 and 3 to eliminate the y's because 1 is positive, 1 is negative in each case. So we're going to put 1 and 2 and 2 and 3. I'm going to have x plus y minus z equals 2. X minus y minus z equals 2. In here, the y's will eliminate. So I'll be left with 2x minus 2z equals 4. And in here, I never thought that my eyes would hurt so much by moving them back and forth so frequently to make sure that I'm writing the right numbers down, or I guess the right letters also. Okay, so in here, again, the y's will cancel because I have 1 positive, 1 negative. And I'm going to be left with 4x minus 4z equals 8. And one thing that I want to mention here is I can actually divide everything here by 4 to give myself simpler numbers. And I can divide everything here by 2 to give myself simpler numbers. And when I do that, I end up with x minus z equals 2. And when I do that here, I'm going to end up with x minus z equals 2. Now, if you'll notice, this equation here and this equation here are identical. And this is really good news because the less math you have to do in math class, the less chances of error you have, right? So in here, I'm going to have this x minus 2 equals x minus z equals 2, x minus z equals 2, because they are the same, because I have the same equation, okay, I am going to have what's called infinitely many solutions. Infinitely many solutions. Now, here's a couple of things about this. Some teachers like this infinitely many solutions right now. Some are just like, hey, IMS is cool. Some prefer all real numbers. I mean, there's also imaginary numbers, but we haven't covered that yet here, especially so early in the book. So something that you're going to see is some version of everything works. Okay. So this homework assignment was submitted by a student. If you have any homework questions that you would like to have recorded, please do not hesitate to send me a message, and I will do my best to record them as soon as humanly possible. I'll see you next video. Bye.